So in the last section, we defined the derivative at a point. Okay? So we discussed the derivative function at a point. And we gave this definition here. Okay? Of course, we have to add provided the limit exists. Boy, he sure makes me write that a lot. Might be important. Okay? Okay. All right. In this section, we're going to define the derivative as a function in its own right. We're going to think of the derivative as its own function. It'll have a graph, it'll have a domain, it'll have a range, and we'll talk about it in its own right. Before we get there, I want to introduce some vocabulary. Okay? If the derivative of f exists at a point, then we can shorthand that by saying f is differentiable at that point. Okay? For some reason, that word differentiable starts to look a little scary to folks. Okay? When I say differentiable, I just mean you can find the derivative there. Okay? You can find the derivative at that point. Okay? Well, if f prime of a exists for all a in some interval, okay, then we say that f is differentiable on that interval. If f is differentiable for every number in the real number line, then we would say that f is everywhere differentiable, or we'll just say f is differentiable and mean that it means everywhere. All right. So now here comes the new definition. Suppose f is differentiable on I, then we can define a new function, f prime of x, called the derivative of f. Okay. And the derivative of f is defined to be the limit. In fact, let's denote it. It's f prime of x, and that equals the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, this is not something I'm going to purposely trip you up on. I'm never going to ask a question just to see if I can catch you. But it is important to recognize the difference between these two things. F prime of a returns a value, i.e. it's a number. Okay. Whereas f of x is a function. Okay. So I need you to recognize the difference between f prime of a versus f prime of a variable x. You need to be able to see the difference between the two. Okay? In fact, you probably heard, it's easy to mix them up. You probably heard me a couple times as I started to give off the definition of the derivative at a point. I started giving the actual definition of the derivative as a function. I would say x plus h instead of a plus h. Okay? So it's easy to get the two confused. And normally I won't try to hold that against you. But it is essential that you realize, hey, this is a number. Specifically, it is the slope of the tangent line when x is a, versus this is a function. You can think of the derivative as a function that you input the coordinate, the x value, and it will output the slope of the tangent line. But it's still a function. So let me say that again. Here you input the x-coordinate, and it outputs the slope of the tangent line at that point. Okay? What's that?
What did you say?
You input the x-coordinate, and it outputs the slope of the function at that point. Okay? Actually, I should say the slope of the tangent line at that point. Okay? All right. This is good medicine. You guys should do this every morning between now and the next exam. Okay? Just put it right next to your cereal, right? And just as you're eating your cereal in the morning, work through this problem. Okay? here's a function. I want you to sketch a graph of this function's derivative. Okay. We'll take a few points. Okay. If I pick an x value to the left of maybe a half here, and I sketch the tangent line, what's the slope on that tangent line? Negative. Or if I pick this one right here, it's negative. Okay? It doesn't become 0 until about right here. Okay? So let's be very careful. This is the ordered pair on the graph 1 half comma 1. This is the ordered pair on the graph 1 half comma 1. But what is the slope of the tangent line there? Okay? So, what does the derivative do? It's a function that says, okay, take this as your x-coordinate and output the slope of the tangent line. So this right here, 1 half comma 0, is a point on the graph of the derivative. Okay. So here was the ordered pair 1 half comma 1 on the graph of the function. At that point, the slope of the tangent line was 0, and so the derivative outputs a 0 at that x-coordinate. The derivative would have been outputting negative values until we got there. So the derivative might have been doing something like that until we got to 0. After I leave 1 half, what's the slope on the tangent line for a little while? It's got what type of slope? Positive. Until I get to right about here. I'm not sure where that is. Let's go ahead and call it 3 halves. I'm not sure. Okay. So at 3 halves, the derivative is again what? At 3 halves, the derivative is again 0. That's probably too far to draw that. At 3 halves, the derivative is again 0. Okay. And what was the sign on the derivative between x equals a half and x equals 3 halves? Because the slopes of the tangent lines were positive there. So it looks something like that. Okay. I'm not concerned with getting actual numbers on this just yet. Okay. I'm just getting the shape of the graph down. Okay. Notice that between 3 halves and I don't know, let's pretend that that's let's pretend that that's 4 here. Okay. Between 3 halves and 4, what is my function doing? It's decreasing. As I go from 3 halves, yeah, I asked these open-ended questions and I have a very specific answer I'm looking for. Sorry. Okay. What's it doing between 3 halves and 4? It's decreasing. What should be the output of the derivative then? Negative. Okay. So the output of the derivative would be something like that until we get to 4, where we again have a horizontal tangent line. So the derivative's graph looks something like that. Okay. So let's label it. From here on out, do not draw a graph. You remember you had teachers that when you first drew graphs, label them. Why? Because now we're going to have several graphs that we're talking about. And it's essential that you keep them straight. So this is f prime of x as opposed to this one over here, which is f of x. Okay. All right. This is a very good exercise to try to take a graph and draw its derivative. If you want an even better exercise, take a derivative and try to draw one of the many possible graphs that would work for it. Okay? Spend some time getting comfortable. Up to this point, this class has been a very algebraic class, very analytic class, but calculus is actually kind of a visual topic. Okay? So oftentimes what I think you should do is whenever you work with a function, go ahead and also sketch its derivative. And look at those two graphs and think about them. Spend a little bit of time. Okay? The most important word to avoid using for the rest of this class is the pronoun its. Okay? Try to avoid using the pronoun it or its, possessive pronoun, its. I don't know English. Sorry, I don't know what that's called. Try to avoid using the word its. Okay? So, when f is increasing, we notice that f prime of x is positive. This is absolutely essential that you get these facts down.
F of x or just
Well, I could write f of x or just f. So if I just write f, it's implied to be f of x. But let me just kind of let me keep it consistent. So when f of x is increasing, although oftentimes I'll just write f and f prime without the of x part. Yeah. Okay. When f, in fact, I'll do it this way. When f is decreasing, f prime is negative. This is a two-way street. If f prime is positive, we know the original function must have been increasing. Okay? Now, listen to how you can get into a lot of trouble here and never be very precise in what you're working with. If I say, when it's increasing, it's positive, I'm going to get very confused as to what the heck I'm talking about. Okay? When f is increasing, f prime is positive. Make sure you say the whole thing. Okay? Likewise, when f prime equals 0, f, can I say that? Yes, I think so. F has a horizontal tangent line. So I gave this fact backwards. You could maybe turn that around if you wanted to. When f has a horizontal tangent line, f prime equals 0. Okay. There is a lot more to recognize in this, but you need to get started. So spending some time looking at a function and its derivative will be extremely helpful over the next unit and a half, 2 units, I think. Okay. Next page. What's going on here? All right, are we on number 7? Is that the next thing to come up? Great. All right. So here I'm asking you to calculate f prime of x. This is a little bit more complicated than before. Okay? Folks, I'm about to cube something. I'm going to cube it in my head. Okay? When you go to cube something, how do you do it? If I want to cube a plus b, what do? I write a plus b times a plus b times a plus b. Then I FOIL 2 of them. That gives me a squared plus 2ab plus b squared. Then I multiply that again by a plus b. When you do so, you get a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so I'm about to use this fact in the middle of the problem. Okay? I'll show you some shortcuts for doing that in your head, maybe at the end of, actually, probably not till Wednesday. Okay? So, we want to find the derivative of this. We're going to have to use the limit definition here. Okay? So, f prime of x is equal to the limit, as h approaches 0, of f of x plus h minus f of x all over h, which equals the limit as h approaches 0 of x plus h cubed minus x plus h minus x cubed minus x all over h. Can you guys read that, or I need to clean that up? It's a little ugly. So notice what I'm doing. I'm just taking the definition of the function and replacing all the x's with x plus h's where it applies. Okay. So this gives us the limit as h approaches 0. I'm going to cube this out now. So this is x cubed plus 3x squared h plus 3x h cubed, no, h squared, plus h cubed minus x minus h minus x cubed plus x all over h. Okay, can you guys read that if you need to? Getting the sighs. Late evening sighs. okay, math has no feelings. You can say what you want about it. Okay? Because this was a polynomial, the same rules apply. How do I know I'm on the right track? Every term that doesn't have an h in it cancels out. Okay, please, folks. I can't tell you how many times I've told that to a group of students, and there's always a couple of them that say, okay, well, the terms aren't canceling, but I'll just get rid of them. No, if they're not canceling, it means you missed something. Okay? This gives us the limit as h approaches 0 of 3x. I'm going to go ahead and factor out the h and cancel it in one step. 3x squared plus 3xh plus h squared minus 1. So I factor out an h and canceled it with the h in the denominator. And so we end up with 3x squared minus 1 when we let h go to 0. Folks, I probably would not ask you one this long on a test. Okay? But, as I said before, if you know calculus already, you can't use shortcuts if I ask you to find the derivative using the limit definition. Okay? Now you can check your answer. That's nice. Okay? But you can't use shortcuts. Yeah, so when I let h go to 0, this gave me 3x times 0. And this, when I let h go to 0, gave me 0 squared. Yep. Good. Other questions? 8, 10, 12, 13, 16, 17, 18, 19, 20. Okay. The reason why I chose this one is not because I wanted you to do that derivative, although I wanted you to see, yes, they can get a little bit more unwieldy, okay? But because I wanted to graph this thing. Okay? So the graph of the cubic, well, let's go ahead and see. If I put this into factored form, I could factor out an x, so I'd be left with x times x minus 1 times x plus 1. So this has zeros at x equals 0, x equals 1, and x equals minus 1. Okay. And why don't I get the whole graph up? Because I don't want to, and then you copy it. Okay. So the graph of this looks something like this. Let me fix that just a little bit. Not the prettiest cubic. Okay, there's the graph of that cubic. This is the graph of f of x. Okay. I'd now like to graph f prime of x, which looks like this. Here's the graph of f prime of x. Okay. Whenever you have the opportunity to graph both the function and its derivative, I think you should. Okay? Going forward, you should use a computer drawing program to kind of speed this process up. Okay? But I think it's worth putting both of these up on the board. Yes, sir?
I'm just going to have you correct the graph, the function graph, the first one.
Uh-huh.
The prime is decreasing till x of 0. But you have it going upward, so it's technically increasing at around like negative 1-ish to 0. As far as like what the function is doing versus what the...
Well, so this function, blue is increasing whenever red is positive. So this is, blue is the function,
Right.
red is the derivative?
Yeah.
So so careful. This is where you got to be careful, right? It's not, so be careful when you're using the word positive and negative and increasing, decreasing.
Mm-hmm.
When blue is increasing, where is blue increasing? From here to here, right?
Right.
When blue is increasing, red is positive.
Or positive, yeah.
When the function is increasing, the derivative is positive. When the function is decreasing, the derivative is negative. And when the function is again increasing, the derivative is again positive. And what I was trying to be careful to do, and this is why I said wait for just a second, was to make sure that the 0 of this corresponded with the horizontal tangent line of this, and the 0 of this corresponded with the horizontal tangent line with this. So, I didn't make a mistake this time, but you watch me. Just wait, I will. Okay? Yeah. In fact, that was precisely the analysis that I wanted to go through. So let's just talk about that one more time. Okay? Again, this is why you got to be careful, because my suspicion of what Matthew accidentally did was he said when it's increasing, it's positive, but he flipped the two. Okay? Or some version of that happened. And it's very easy to do. Okay? So notice that sometimes blue is positive, sometimes blue is negative. Red doesn't say anything about that. Red doesn't tell you when blue is positive or negative. Red tells you when blue is increasing or decreasing. Okay? In fact, there are many other functions that would have had this exact same derivative. Okay?
So could you essentially move the f of x function up and down the y-axis?
Yes.
And the f prime of x graph would be the same.
So
essentially?
if this were some other function right here that's an exact, well, that's not exact, that's a copy of this one just shifted up 3 units, or 7 units, or 20 units, whatever. No, it's not the prettiest of pictures. This would still essentially be its derivative. When black is increasing, red is positive. When black is decreasing, yeah, I didn't quite get it. Red is negative. Anyway, but yes.
Okay.
Okay. So this is very important. The derivative does not tell you whether you're positive or negative, whether the original function is positive or negative. It tells you whether the original function is increasing or decreasing. So that's why you got to be very careful as to what information is provided from the graph of the function versus what information is provided by the graph of the function's derivative. Okay? I equate this to trying to write your name backwards in a mirror. You all can do it, but it takes a lot of concentration. Okay? All right. So spend a little bit of time looking at this. Okay? All right. Here's the next one. I asked you to do several things at once here. Up until now, I've been making you write the limit definition of the derivative, and I've been making you write provided the limit exists. We've not seen an example where the limit hasn't existed yet. Okay? We're not going to quite see that here, but this is what I mean by we got to be a little more careful sometimes. So, what is the domain of f? Okay, what do we mean by 0 to infinity?
Can't be renamed.
So what about 0?
It's included.
So we include 0 to infinity. Okay? Folks, if you're rusty on the domain of your square root function, it needs to be on a note card. You need to look at it each morning with your Cheerios. Okay? Let's find out what f prime of x is. Okay? I'm getting tired of this. We getting comfortable with this limit definition? Up to a point, you should be. Okay? I think everybody in here should be able to get to this point right here. Oops, I forgot my limit. Yeah. Okay? I think everybody in here should be able to get to this point by now. Okay? Because this part never, from my question to here, it never changes, and I can give you a point or two for that much work. Okay? Now let's go ahead and try our square root technique. So let's multiply this by the square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. This gives us the limit as h approaches 0 of x plus h minus x all over h times radical x plus h plus radical x. Folks, we actually did a problem like I said, it would have been nice if you had a couple days to digest 3.1, because this is the same problem we did in 3.2 at the very end, except we were finding the derivative at a point instead of as a separate function. Okay? So this gives us the limit as h approaches 0 of h over h times radical x plus h plus radical x. So at long last, we're left with the limit as h approaches 0. I'm just going to evaluate it, folks. You guys get the point? Get the point? Of 1 over the square root of x plus 0 plus the square root of x, which gives us 1 over 2 radical x. Okay? I would recommend memorizing this derivative. The derivative of f prime of x is 1 over 2 radical x. Okay? Yes?
So in this function, since you can kind of just know that it's going to be 1 over 2 over x, when you see that x plus h over square root of x plus h minus square root of x over h, you'll know that it will essentially just end up being 1 over 2 square root of x. So we have to show all of that work, or if we already...
There's some shortcutting of steps here, but if you're using the fact that you've already memorized the derivative to give you the answer, then you're doing too much.
Mhm.
Okay? So if you're doing algebra steps in your head, I'm fine with that.
Okay.
Yeah. Okay, so folks, here's f prime of x, right? Let's just reiterate it. F prime of x is 1 over 2 radical x. What is the domain of the derivative? Matthew, what did you say?
0 to infinity,
The domain of f prime of x
but it can't.
is 0 to infinity.
But it can't be bracketed. Yeah.
Now that square root showed up in the denominator, right? And I can take the square root of 0, but I cannot divide by 0, so we now have to exclude this. Okay? This is an essential example for you guys to get down. Okay? What conclusion can we draw regarding the domain of a function versus the domain of its derivative? The domain of the derivative is a subset of the domain of f. By that I mean it could be the same as the domain of f or something smaller, but it could never get bigger. Okay? Okay, I want to draw your attention to what I think is a particularly handy website for drawing graphs and their derivatives quickly. So this might be one called Desmos. You might have heard of this. Okay. I like Desmos for some reasons, not for others. I find it atrocious to try and get the picture the size you want it to be. Okay. But one handy tool of it is that here I've typed in a function, which is a very interesting function, by the way. Notice how it's essentially cubic. This radical term has an influence, but the main impact of the radical term is it truncates the domain slightly. This is no longer defined between 0 and 1, which is really interesting. Okay? So maybe just do some exploring with that, but what I wanted to show you is if I want to graph the derivative, I can type it in, actually what the derivative is, or I could just say, tell me f prime of x, and it computes it for you. Okay? There are some flaws to this. Okay? It's not perfect. I've found plenty of errors with it. But for most functions that we work in this class, you could type in f of x and then type its derivative, and it'll show it for you. Okay? What's interesting here is now playing the game of red is the function, blue is the derivative. When red is increasing, between here and here, blue is positive. Okay? Notice that blue becomes, red starts to have very negative tangent lines right here, which is precisely where the derivative is undefined. Okay? Lots of interesting stuff to see with this. Let me just put up the one we just did, though. So typing a square root is a little bit hard in there. It's just lowercase sqrt. Some of those commands are similar to the MyMathLab commands. So here's your square root curve. When I graph its derivative, so notice that anywhere along here, look, I can draw the slope, I can draw a tangent line and compute its slope, right? But as I move closer and closer to 0, what's happening to my slopes of the tangent lines? They're getting steeper, getting close to vertical. What did we call a vertical line? We said that its slope was undefined, right? Math people are actually very careful about their terminology, believe it or not. When we said it was undefined, that's precisely related to the fact that the derivative was what? Undefined at 0. What does the derivative do? It gives you the slope of the tangent line. And so let's put the derivative of f up there. So we could either type it in what we just computed it to be, or here we can look at it. And you can see that it has this 1/2 radical x shape to it, and the tangent line is undefined at x equals 0.